Hi, ladies, Mr. O'Sullivan. Today, we just had our Zoom lesson where we went over the distance formula, but now we're going to look at the distance formula using the Pythagorean theorem. So today's learning target is, I can calculate the distance between 2 points by using the Pythagorean theorem. So earlier we went over how to find the distance between 2 points by using the distance formula, which is d is equal to the square root, I'll write it in, d is equal to the square root. Ooh, let me make it a bigger square root of x2 minus x1 squared plus y2 minus y1 squared. What we're going to look at now is we're going to look at how we can use the Pythagorean theorem to find our missing side length. So again, Miss Daniel mentioned that the distance formula is extremely just the Pythagorean theorem, just a little different. So here's our problem. Suppose you're given the 2 points, -2, 1, and 1, 5, and we want you to find out how far apart they are. How would you do so? Well, here's what you do. We have our line segment. What I'm going to do is I'm going to label these points A and B. So this is -2, 1, and this is B1, 5. Yep, this is B1, 5. If I wanted to, I can actually make a right triangle. So what I'm going to do is I'm actually going to make a right triangle so that my segments actually line up with each other. I'll make the side blue, and I'll go from -2 to 1. Good. And then I'll draw a, not green, let's do red or maroon. And look, now I have my right triangle. I'm going to put in my right angle. And we know that we have a right angle right here, which means that this has to be our hypotenuse, or the segment we want to find the distance of. So what we now need to do is we need to find out what the length of our base segment is. Well, if we look, we start at -2 and we go to 1. That means I go from -2 to 0 by 2 and then to 1. So 3. So what I can say about this segment is that my length is 3. Now I want to find the height of my segment. Well, if I'm starting at 1, right here, if I'm starting at 1 and I go all the way up to 5, then I'm really going up by 4. So I can say that this segment is 4. Now what we want to do is we want to use the Pythagorean theorem to find out what our missing side length is. So we have a squared plus b squared is equal to c squared. So I have a squared plus b squared equals c squared. Well, I can make 3 or my 4 my a, and I can make 3 or 4 my b, as long as I'm just consistent. So I'll make 3 my a, and I'll make 4 my b. So now let's do our substitutions. So we have 3 squared plus 4 squared equals c squared. And that's what I want to find. Well, I need to ask myself, what's 3 times 3? Well, 3 times 3 is 9. What's 4 times 4? 4 times 4 is 16. And that's equal to c squared. I now say to myself, what's 9 plus 16? Well, 9 plus 16 is 25. And I get that's equal to c squared. The only way to get rid of that square is to take the square root of both sides. So I take the square root, and I get c is equal to radical 25. So some of you know that radical 25 is just going to be equal to 5. So I'm going to just write down c equals 5, and that's your final answer. But if you're one of the students who doesn't pick up on that right away, it's not a big deal. What we can do is we can just go to the side of our paper, and we can find out the prime factorization of 25. Well, I can break apart a 25 into 5 times 5. I'm going to circle my primes. I'm going to put those under my radical. So I have radical 5 times 5. The rule is double on the inside, single on the outside. So I have a double 5, and it becomes single on the outside. So I'm just left with 5. That's how I get 5 as my final answer. So I can say my missing side length is 5, or my distance between the points A and B is 5. Good, now we're back to business. So I can do the distance formula and now say 2 minus y1 squared. So I'm going to go back to my question and copy and paste these points because I don't feel like rewriting them. And I want to find the distance between these 2 points. So a lot of us during class day, we really were very quick. We knew what our second x was. We knew what our first x was. We knew what our first y was. We knew what our second y was. So again, if you need to color code, go ahead and color code. I have to color code or I'm going to make a mistake with my questions. So I have distance is equal to, the first thing I want to ask myself is what's my second x? Well, my second x is a 1 and my first x is a -2. Make sure you wrap that -2 in parentheses. So I have 1 minus -2. I'm going to square that whole expression. Now let's do our y's. Well, my second y is a 5 and my first y is a 1. So I'm going to be doing 5 minus 1. And I'm going to square it. Ooh, black this time. So d is equal to the square root. 1 minus -2 is 3. I'm going to square it. 5 minus 1 is 4. I'm going to square it. Remember, if you get a negative number, make sure you put that negative number in parentheses. So don't just write -4 squared, write parentheses -4 squared. So now I have distance is equal to the square root. 3 squared is 9. 4 squared is 16. What's 9 plus 16? 25. So distance is equal to square root 25. And we did it before. Our distance is just going to be equal to 5 because the square root of 25 is 5. So 2 ways of doing it, both extremely, extremely similar. But one way you're really just doing the Pythagorean theorem. The other is the exact same thing, distance formula though. If you have any questions, please email myself or Ms. Daniel. Have a great day, ladies.